Okay, I thought we talked for a minute about secure programming and buffer overflows. So why do we care? Well, let's first talk about a buffer overflow. Once again, a buffer overflow occurs when a program or process tries to store more data in a buffer than it was intended to hold. Now, a buffer is a temporary data storage area. Sometimes when we're coding programs, we need our program to store some intermediary value so that we can later on use it later on in our program. Since those buffers are created to contain a finite amount of data, the extra information, which has to go somewhere, can overflow into adjacent buffers, corrupting or overriding the valid data held in them. So consider again, for example, on a running machine, we might have lots of different programs running. Each of those programs is running in their certain allocated set of memory in their certain registers on RAM. If we can get one of those programs to leave or jump out of that memory location and go over into another memory location where another program is running, we could cause bad things to happen. And in the example assignment you're going to do a just simple buffer overflow where we have a simple C code that is expecting just a simple string input, and we are going to jump out of that program execution and jump back to a shell. So that is one example of a buffer overflow. And I'll show you another example here in a minute. So watch this video down here on your own time and learn more about buffer overflows. But it's kind of hard. It's difficult to identify buffer overflows. There's people that do them, but you have to have, especially for a desktop software application or any sort of application, you need to have specialized knowledge of how memory is stored, how the stack and the heap work within a process. And you can go research those terms if you want and learn a little bit about how processes store their memory. So it does take a little bit of extra knowledge, but we need to be aware of how these are occurring so we can protect. So the attacker needs to be able to identify a buffer overflow in some program and understand how that will be stored in the process memory and know what other adjacent memory items he could write to. We could denial of service the system. We could do a lot of bad things. We could cause the other program to do things on our behalf. One way we can identify a buffer overflow is through a technique called fuzzing. Now, I'm not going to spend a ton of time on fuzzing right now or in this class. You could go research more about it. Kali does have some fuzzers built into it. But fuzzing, all it really is involves sending malformed strings into the application or web application and watching for unexpected crashes. After finding the malformed input, you could then use the assembly to figure out how to deliver shellcode or how to deliver the exploit. So, yeah, that's a very generic definition of fuzzing. But once again, it's just sending a bunch of malformed strings into the application until you get it to crash. And there are tools that will do this for you, and then from there you can craft your own special string to get it to do what you want. Fuzzing does actually have a practical usage in software development to make sure that you're coding correctly. So there's some you can go look at in Kali if you want. Watch these other two videos. There's one video on fuzzing, and then this OWASP will give you a trivial example of fuzzing, so you can read that on your own time. So why are programs vulnerable to buffer overflows? Well, first of all, probably poor programming. And are all programs vulnerable to buffer overflows? No, generally it's those that are coded in lower level languages like C or C++, because in those languages you are in charge of making sure that you are allocating your buffers correctly. You actually are allocating and creating, managing memory, cleaning up your memory programmatically, versus in Python, which a lot of us have used. Python takes care of all this allocation for us. So Python is a lot less susceptible to buffer overflows. PHP less susceptible to buffer overflows. Any higher level language is not very susceptible, but C, C++, those are the two most common ones that are susceptible to buffer overflows. And there's still a lot of stuff written using C or C++. The computer really doesn't care when you're using these lower level languages. It'll do whatever you tell it to do. So if you're not telling it to do the right stuff, then you've got a problem. How do we protect against a buffer overflow? Well, there's some compile time defenses, which you will experiment with as you do your lab. Choose a higher level language. Don't use C or C++ or some of those lower level languages. Handle failure gracefully. Address space layout randomization. You're going to do this in your lab as well, but if I randomize every time a program runs, if I can get it to run at a different memory location, it's going to be a lot harder for me to figure out when I do a buffer overflow where I need to jump out to execute malicious string and to jump into another program. If whenever those programs run, they're always running at a different address, it's a lot harder to do that. Now, right now, most versions of Linux that I'm aware of come with address space layout randomization turned on by default, but that wasn't always the case. And you can read about the NX bit. One example I wanted to show you was this. Now, this looks like a bunch of gobbledygook to you, so let me tell you the story on this. This is an example of a buffer overflow. Several years ago, we had email server running, XM service. And this service, we came to realize after the fact, was not the most current version of XM. It had some patches that we should have applied to it, so it was running unpatched. There was an exploit available for it. The exploit was a known buffer overflow attack. And anyway, so this was running. We didn't realize the service was running on the machine it was running on, but I captured it because I thought it was very interesting to see how the buffer overflow was performed. Now, basically, what they would do is our mail server was set up, and they would just send specially crafted email messages to our mail server till they overflowed the buffer. So you can see, for example, they're just sending an email message to us with a bunch of headers. Now look at all this. Why do you suppose they're putting all that in there? Well, they're just putting characters in, fill up space until they overflow the buffer. So, and then in this header information, look at this. They've got some wget stuff going on that will go download a file, and then they have maybe running a Perl command, and pretty much they just do that over and over and over again, and if they can get, and you'll see on your assignment, if you can get it to jump to a shell and do something like that, especially if that script that I'm downloading is a executable or a script that I can run and do bad stuff, then and they were successful. They were able to successfully send, all they did was send a specially crafted email message to our mail server. Our mail server then processed it, and it eventually ended up executing whatever these commands do, which would download a script and run it, and we were hacked. They then installed a backdoor and got access to our machine. So that was one access of a buffer overflow that I dealt with. It was interesting. So just a couple last things that talk about buffer overflows. We need to make sure we follow secure programming principles. As you consider the software development lifecycle, a couple steps of the software development lifecycle are to maintain and test your code, critical unit tests on your code, validating input. So we're always talking about input validation, one of the key things of security. Least privilege principle. Don't let users do things they shouldn't be able to do. Don't let your code be able to access files or folders that it shouldn't. Don't let it run as users that it shouldn't run as. Remove unused functions. If your code doesn't need those functions anymore, remove them. Fails securely. Use try-catch blocks or exceptions. Patch and fix issues correctly. If we would have patched our XM server, we would have not got hacked. So stay up to date on patches. If you go look at WordPress, they probably have patches every month to fix different issues, and they have been susceptible to buffer overflows in the past. So we kind of talked about that. Never make any assumption about your code. Secure programming. Most programmers focus on solving a problem rather than considering every point of failure. They often make assumptions about the input and the environment it executes in. We always often think that, people will always use our code the way that we think they should. They'll always pass in inputs that we expect they should, but that's not the case. We should always validate all input, handle potential failures, and we have to do this, consider this in the design phase of the development rather than as an afterthought. So the areas of input that we care about are the size of the input and the meaning and interpretation of input. We kind of already said that, don't make assumptions, validate everything. Let's see, if you're expecting a file name, does the input follow a typical file name pattern? Are they actually passing in, if we're expecting them to pass in the letters A through Z for a username, are we really validating that's what they're passing in rather than some weird, $, escape characters, stuff like that? So we really need to be careful about that. So that's all I have to say on buffer overflows.